Hello everyone, welcome back. Today we'll be teaching you the MOSFET board. For those of you watching our videos for the first time, you could refer to our previous videos to know what we're talking about. What we're practically doing here is how to build an inverter from home, and you could also feel free to subscribe to get follow-ups on our latest updates on things like this. We won't just be showing you inverters, we're showing so many other things in this engineering hub. Also do well to share to your friends so they will come and get this practical knowledge here. So now this is the MOSFET board. This is what it actually looks like. This is what it looks like. This is it. Now this MOSFET board is built in a system called the H-bridge system. The H-bridge system, as you can see here in the paperwork. You can see here on the paperwork. This is a H-bridge system. It is designed in such a way that it has a H format. You can see it. Now, in this MOSFET board, it has the high side. This is the high side and the low side. Now, from the diagram, let me use the diagram to illustrate what I'm saying. On this diagram, we have the high side and the low side. So this is where the high side is being connected to the low side in the secretarial diagram. Now, from what we have here, the drain of the two high sides are connected to each other, and this is the high side. You know, in this MOSFET resistor, you have the gate, the drain, and the source. And don't forget that this place connected to the heat sink are part of the drain. So, for this all parts here to be connected to the heat sink, means that the whole drain is connected. So this is the high side. In the high side, the whole drain is connected, and this is where the positive of the battery that is supplied to the inverter is being connected to, as you can see in our secretarial diagram here. Now, this is the low side. In the low side, the drains are separated, and it's very obvious here. The heat sinks are separated, therefore the drains are separated. Now I have what is called the gate resistors. These are the resistors used to ground the gates. Now the gate resistors, we built a 1.5 kV inverter. So the higher the power of the inverter, the lower the gate resistor is used. And we have what we call the grounding resistor too. Then you use your capacitors for polarity to finally divide the polarity of the battery. So now this is the pin, the output pin that you use a flex to connect this output pin to the other oscillator board we talked about earlier in our previous videos. Now this pin, I'll give you the configurations here. This is it. The pin 1 is the H1, which is the high one of the gates 1. You can see it. This book or this write-up is simply describing everything about this MOSFET board. You can see the H1, the D1, the L1 is the low side, the H2, D2. You could see them yourself here. Everything is on this paper, and we're using the MOSFET we're using here is IRF 3205. 3205, and the power capacity is 200 watts. So we also have the current sense. So all this is the way the MOSFET board is connected to the oscillator board. Now, for those of you who are very good in technology and in circuitry designs, you could easily use this H-bridge system to build your own inverter. Probably after you made your own oscillator board, then this H-bridge system is a key simple component you can easily attach to your oscillator board to help you build a good get more infos on this. We are coming up with something more for you guys to fully understand how our inverter works and how to build yours from home. Also share this video to people you love so they also learn practical ways of making things happen on their own from home. Thank you. See you, men engineering hub.